Hello, good evening. Welcome to GlugNet. My name is Stephen Ball, and I am serving as the president of GlugNet. Tonight, we are pleased to welcome Chris Woodruff, who will be speaking to us about Rust-ifying your C-sharp codebase. But before we get started, a little bit about us. We are the Greater Lansing user group for .NET developers, based out of Okemos, Michigan. Our meetings are free and open to the public, held every month on the third Thursday. The best way to find out more information about who we've got coming up and what we're talking about is if you go to meetup.com/glugnet. Most of our meetups are recorded and posted to YouTube by Sam Nasser. You can find a link and a QR code on the screen right now to his channel. A few housekeeping items. We are always looking for lightning talks before our featured presentation. If you have a topic that you can talk 10 to 15 minutes on and are interested, you can contact either myself or Joe Kunk, and we will get you slotted into a meeting. Additionally, tonight's presentation is intended to be interactive. We encourage questions, discussion throughout the presentation. If you've got something you'd like to say, please feel free to unmute and ask your question. If you are unable to or just uncomfortable doing so, we understand. There is a chat feature in GoToMeeting. We will be monitoring that for questions and comments as well. Otherwise, we just ask that you please stay muted so we can all hear and enjoy the presentation. At the conclusion of tonight's presentation, there will be a survey made available to all attendees. We're looking for feedback in two areas primarily: the promotion of this event and the content of the event itself, the speaker, the slides, that sort of thing. All the feedback collected is completely anonymous. So please leave your honest feedback, good, bad, somewhere in the middle. We want to hear it. A summary of that feedback is then gathered up and sent to our speaker so he can improve this talk for future iterations of it. So if you would please consider filling that out at the end of the meeting, we would greatly appreciate it. At this time, I'd like to thank our sponsors for the evening: NIS Technologies, providing this go-to session, and the .NET Foundation, who provides financial support for the organization. And now time for our featured presentation.
Okay, so we're going to be talking about Rust. And every year I have a goal to learn 3 new things. And those 3 things could be really anything. Sometimes it's some languages or frameworks or just learning about something outside of technology. But this year and last year, I picked Rust because I had heard a lot about it. In college I did C and C++, and I heard Rust was kind of the next generation of C++, and it was kind of that down on the metal language, and it was good for performance and stuff, and I wanted to get into it. And so I got into it. I'm learning. I'm not an expert in it. If you ask me questions and I don't know, I'm not going to tell you anything else than I don't know, and I'll probably make me go learn about it. But I think learning how Rust compares to C# will give you a good kind of level set and a good outlook if you do want to look at Rust for projects down the road. So we can just dig right into it. So again, this talk is a talk. It's going to be all slides. It's going to be talking about what happens when C# and .NET doesn't meet the needs for a project that you're doing. So maybe you're doing something that has to have a lot more performance, Maybe it has to work on some hardware that maybe .NET doesn't work so well on. That usually doesn't happen, but you never know. So, but we're just going to talk and have a friendly banter about Rust and C Sharp, and hopefully at the end of the night you'll learn a little bit more about Rust, and maybe it might make you go learn it and be a little more proficient with it. So let's start out in talking about what C Sharp is good at. So we all know C Sharp is very well in the web development space with ASP.NET Core. We also know because .NET and C Sharp are a Microsoft product and a Microsoft created language, that the cloud it it, it does very well on Azure. It actually does very well on AWS also. So that's why I didn't put Azure up here. I said cloud because it does work well on the two major cloud platforms that most companies and developers use every day. Windows apps. So we use it for all the way back in WinForms to Maui today to Apollonia. There's lots of different things that C Sharp Blazor. So we can do Blazor apps inside Maui. Lots of different ways to get Windows apps that are not web apps, but are actually Windows apps. And then for all the web developers out there, C Sharp is a great language to use with Unity. And there's lots of developers that create video games that we all use, and they are developed in C Sharp with the Unity engine. They're good for web APIs. I create tons of web APIs, RESTful APIs in .NET and C Sharp. So let's take a look now at Rust. So Rust kind of grew up in a different path. So it's really good for system level development. That's kind of where things started in the when Rust first was created. It became really popular in system level and operating systems. It's good if you need WebAssembly and WASM apps. So it lends itself for that because it's really small when it's compiled. It's small, tight, fast, and efficient. Embedded systems, you can run Rust on everything small. They do Rust on a lot of internet or small devices on the internet. Raspberry Pis, you can run Rust on Raspberry Pis. Interesting stuff. Networking systems, a lot of Rust is developed for routers and other networking systems that are on the internet and help us transport all those packets all over the place. Cryptography, there's lots of good libraries for cryptography, and anything around encryption. Rust is really good because it's fast, it's very efficient, and yeah, so it's good for stuff like that. And it's also good for web development. People have started building frameworks for web development and web APIs. So it's not super popular for web development. I think it's more popular for web APIs and getting RESTful APIs up on the internet, but you can do web development in it. So let's take a look at the language syntax between C Sharp and Rust and see how they compare and contrast. So let's compare some of these paradigms. So we all know, since we're at a .NET user group, a lot of these things for C Sharp, most people should know, but C Sharp is a heavily geared language for object-oriented programming. And it uses classes, inheritances, and interfaces. And we work in that paradigm every day. Rust is different. Rust supports OOP principles, but it uses structs and traits, and we'll learn more about those in this talk, and I'll show some code and how we kind of do our OOP. So it doesn't have the same type of inheritance that you see in C Sharp and a lot of other object-oriented programming languages. It uses kind of a different way of inheriting, and it's not inheriting from one base class to the next. It's really inheriting these behaviors. So taking behaviors that you develop and bringing them in to a struct, which is, think of a struct as like a C Sharp structure. But we'll take a look at that, and it might be confusing right now, but hopefully it won't be in a little while. So C Sharp relies on garbage collection. It uses that to manage memory. If anyone truly understands the garbage collector, please come talk to me, because I've always wanted to learn everything about the garbage collector. It is a complex machine, and if anyone really, I think there's only like 5 people in the whole world that truly understands what garbage collection, how it actually works. So, but for Rust is a lot easier. Rust has an ownership model, and that means that when a piece of memory no longer has an owner, so think of it as a pointer, if anyone remembers C++ or C, we have pointers. So Rust, if nothing is pointing at a piece of memory that has a value in it, Rust takes it away and it goes away. So it's very efficient at memory. It doesn't wait to give memory back. So C Sharp and the garbage collector, sometimes it takes a while for these objects to go through the garbage collector and get disposed of if they're managed resources. Unmanaged resources we can get rid of whenever we want, but managed resources we need to let the garbage collector kind of handle those, and sometimes it takes a while. But with Rust, doesn't have an owner anymore. It's gone, and it's available for the system. Both languages support functional programming. Rust has a pattern matching, and Rust has immutability by default, and we'll talk about that. I have a whole slide on that. C Sharp has their link and lambda expressions, which can lend itself to functional paradigms and functional programming kind of patterns. And then Rust hard word to say today. Rust's concurrency model, built on this ownership system, really ensures that compile time guarantees against data races. We'll take a look at that. It's much safer than C Sharp's threading model, because we are only the variables that we use can only be used in certain ways, and the compiler can detect if we are going to use a variable that will not allow concurrency to happen, or will cause concurrency issues, and it won't let us compile that Rust code. So it's pretty cool how it figures out all that. So both languages support async programming with the similar syntax with async and await. So let's take a look at some simple code examples. So on the left-hand side, we have C#. So we see we have creating a new integer, creating a new string, and creating a new Boolean. We work with this type of variable creation every day. On the right is how Rust creates these variables. And the first is we always have to say let. So let number, let the name of the variable be of a type, and then that is assigned to a value. So for this, we're saying let number, which is an I32, which is integer 32-bit, equal 10. So why we say I32 instead of int is we have lots of different value integer sizes that we can work with. So Rust lets you really work in different sizes for your integers. The next one, string, you can see that we have an ampersand. So this is a way for Rust to say this is kind of a pointer to a piece of memory that holds this string, and then a bool is true or false, and it's the same type of bool that we see pretty much in every language. So here's some functions examples, really simple. We have an add, so we're going to add two integers together, and we're going to return that int. So we can see over here on the left-hand side that we have this C# function, and it returns the product of A plus B. Now in Rust, it's a little different. Now we create a function by fn, and then we have to name that function, and we have to say what the parameters are that get sent into this function. And then we're going to say what the return value is. But inside, it just says A plus B. So this is the first kind of interesting thing with Rust, is Rust anticipates what the return value will be. And it will figure out that usually the last statement, or one of the last statements in your function will give it the value that it returns in that function. So for Rust, you do not have to say return. All you have to do is do your algorithm, do your code, and at the end, it will figure out if it can decipher a return value that was set up in the function creation, or if it can't. If it can't, it'll give you an error. If it can, it'll infer and send that value back. And then string, we're going to do two things that just return string. Both C# and Rust both have interpolation. If I mispronounce that, it allows for kind of variables to be added and created within the string. So for the C#, we embed it in the string, and then for Rust, we actually let it go off at the end, all the values that will be brought into that string and what the string will be based on. These are conditionals, very similar between the two sides. C# has ifs and else that we use every day. Rust has ifs and else. The biggest difference is that you'll see we don't have to have parentheses on Rust. You don't use parentheses for your conditionals. So otherwise, it's pretty much the same for most of the conditionals between C# and Rust. Loops, slightly different. So on the left-hand side, we're seeing a for loop and a while loop for C#. We use these every day in our code. But for the Rust side, a for loop is handled a little differently. We just have to say for I in, and then we give a set that it will iterate through. And in this case, it's going to iterate from 0 to 5, and then it's going to print inside the for loop an iteration with that number. Then a while loop is, and this is the first time we're seeing this, is we have to create a mutable variable, and that is why you see the MUT. So by default, all variables in Rust are immutable. So if no one knows what immutable means, it means that a variable that's immutable cannot be changed after the creation of that variable. So the contents of the value that that variable is pointing to cannot be modified, which lends itself to a lot of benefits of Rust, including, and we'll look at later, concurrency. So with a while loop, we have to have a mutable variable because we need to add 1 to that count to have it go through the while loop. So in this case, count is mutable. At the end of the while loop, we're incrementing count by 1, and we're going to go through that loop until count is less than 5, or 5 is greater than count. Maybe that's backwards. Maybe I have that wrong. Probably should be the other way around. So I think I wrote a bug in my slide deck. Okay, so error handling. So this is another area that you have to be really careful with Rust, because Rust does not have the same error handling that we have in C# and .NET. We do not have try catch in Rust. As you can see on the left-hand side, C#, a very common code that we use all the time, try catch. In this case, we're catching a divide by 0 exception, because as you can see, 10 divided by 0 will always give you an exception of trying to divide by 0. Rust, on the other hand, we have to explicitly build the code to handle that error. If we don't, the compiler will not let the code compile. So in this case, we are creating a divide function that takes in 2 int32s. It will return back a result, and this is the other interesting thing. So I'll talk about the result in a second, but let's jump down into our code. So as you can see, we have to check to see if b equals 0, and if it does, we are going to send back or send an error, and an error can have a string, or else we're going to say okay and then divide a to b. Now this is another way that we can handle result sets for functions in Rust. If you go back up to the function definition, you'll see this result, and in brackets, you'll see I32, comma, at static string. And I'm actually, oh, and then the nick, or the little, I don't know what character, the tick, that is just a way for Rust to say that it is a pointer to, it's a dynamic pointer. So it doesn't really mean too much right now. But what the result is saying is I can either get back an int32, or I can get back a string that contains the error if there's an error coming back. So this is the interesting thing with Rust, is you can have multiple values coming back of different types back from a function. So that's why we have ERR, and we give a cannot divide by 0, and then down below, if you can divide A by B, it'll say okay. And that is telling the compiler, I have an error, send back the result as an error string, or send back the result as an integer 32. So that always takes a little bit to understand, that you can have multiple different types of results, and you have to kind of handle that on the return, and so it's just something you have to learn with Rust. So differences in OO between the two, like I said, C# has classes, C# has inheritance, single inheritance from one class to another. And then we can do multiple inheritances through interfaces. And then those interfaces, we all know, define the contract that classes have to be implemented, and that allows for polymorphism. So Rust, on the other side, uses structs. So structs are, think of structs as data structures. They can't hold anything other than variables. They can't have methods, they can't have behaviors, they can't have anything other than a set of variables inside that structure. Traits are where we get our behaviors, where we get our methods that then can be implemented for instructs. And I've got code for all this. But traits are kind of similar to interfaces, where we can have all these traits, and we can say, I just want these 5 to be part of this type, and we can implement those and use it in our code. Rust does not support traditional inheritance. Instead, like I said, it uses trait implementations to achieve polymorphism, and we'll take a look at that in a second. So C#, we've all seen this. We have an interface called iShape, has a method called area that returns a double, and circle adheres to the iShape interface. So because of that contract, it has to have a method that's implemented called area that returns a double. And you can see up here, it also has a constructor, and it has a public variable of radius. This is what Rust has. So if we take a look, we have a trait of shape, and that shape has a function definition of area that takes in tilde, that self, it takes in itself and it returns back a float 64-bit float. The next thing that we have is we have a struct called circle, and that circle has a property called radius, and that is of type float 64. And we are going to implement circle. So we are going to say, hey, implement circle, and I'm going to now give it I'm going to say function new, and it takes in the radius. It's going to return a self, and that is the function that sets the property in our struct. But we can also implement shape for circle. So we can say, I want to take the trait shape and implement it for circle. And what this will do is this will, because area takes in self, we have to do the same thing down here. So this is saying area for a circle is a value of itself. It returns a float 64, just like the trait defines. And down below, it just says that we are going to multiply pi times the radius times the radius. So 2r to the second. Pi times r to the second. But you can also see that we have some extra stuff in here. So we have std : f64 : const : pi. That is the full declaration to get the pi constant. Now there's ways to shorten that, just like we do in .NET and C#. We don't have to fully do the entire namespace that something lives in. We can kind of use uses up above. Rust has something similar, but I wanted to show where pi came from. So pi comes from the standard library under the type float 64 constant, and then there's pi. You can actually get pi in different formats. So you can get pi in a float 32 and a float 16, and there's values that get returned back for pi. So in this case, we have a float 64, which is a very long value for pi. So that's kind of taking a look at some of the code. Anyone have questions? I'm looking over at my other screen. No questions?
Yeah, I've got a question, Chris. So
Sure.
on the return values, you mentioned it tries to determine one, and if it can't, it throws you an error, so like it won't compile at that point if it's not clear what you're trying to return.
Yeah, it won't throw an error at runtime. It actually will not let you compile. So
Okay.
so the Rust compiler is very, I'll say very smart, and it will try to infer a lot of your code. It will look ahead and see if you're allowed to, if the code will cause any problems in the future. So, and then I saw another question from someone: how do you accept the result? And I think I've got code in there. If not, I'll bring up a browser and we'll take a look at that. But good question. How do you accept a return value that can be the type that you're looking for or an error result? So that's a good question. We only accept a result if there were a winner. Okay. Well, sure. Good joke. I like that. Next thing we're going to do is memory management. So Rust has, like we talked about in the beginning, Rust has a very easy way to handle memory. If anyone understands or has looked at garbage collection in C Sharp, this is kind of a very simple drawing that tries to show what happens with the garbage collector. So small objects go into Gen 0 and larger objects go into Gen 2, and the garbage collector will try to free up memory from objects in Gen 0, and if it can't, they get thrown into Gen 1, and it waits around for ownership for those objects to go away, and if it can, then Gen 1 gets freed up by the garbage collector, and if not, they go into Gen 2. And to be honest, that's about all I know about garbage collection. It's very complex. And like I said, I think there's only like 5 people that truly understand the garbage collector. And I think three of those people created the garbage collector in the CLR. So it's very complicated. You never know when your objects are going to actually be freed unless you dispose of them yourself. But even then, they may not be totally freed. So they magically will free up at some point in the future. But Rust is easy. Okay, each value in Rust has an owner. When I create a new variable that has a value, the variable name is the owner of that value. And there can only be one owner at a time. So I can't have, like in C and C++, I can't have multiple pointers pointing at the same memory space. So Rust is very, very stringent on there can only be one owner at a time. But when that value, when that owner goes away because of different things, as whenever that value no longer has an owner, it gets freed up. So when an owner goes out of scope, the value will be dropped. So in here we see a little function, and we let y equal x plus 1, and at the end y gets returned, and that value will get returned. A copy of the value, y goes away because we're not using the actual content from y, which was x plus 1. We're sending back a copy of that value, but the original value that had y set to it, because y now is out of scope, y goes away because it has reached the end of the function. The value that y pointed to also goes away, and that memory comes back to just like x. X goes away even before y. X will lose scope when it is used for the calculation to assign y, and when that new value gets assigned to y, x is no longer needed. X goes away, so the value that was sitting in that was pointed to from x also goes away, and that's how Rust memory management happens. Very simple. If the memory has no owner, the memory is gone. So let's take a look at Rust's ownership and borrowing, because now we're going to add some complexity onto this simple idea of ownership and memory management. So we're going to talk about basic ownership. So we have a function. In the function, we are assigning a string to S1. So S1 owns hello, a string that has the hello characters in it. The next line that says let S2 equal S1, we are transferring the ownership of hello from S1 to S2. So at this point, S1 no longer is in scope, it goes away. Now, the memory, hello, has a new owner, so it doesn't go away. So S2 now owns the string hello. And if you take a look at the line that's commented out, if we didn't have that commented out, then you would get a compile time error because the compiler would say, oh, S1 isn't in scope right now. I can't compile this. So that's because S1 no longer is valid. It has reached the end of its lifetime or scope. Now, the last line, the print line that uses S2, that actually will print the string because S2 took over ownership of the hello string, and it now can be used. So basically, that's the simplest form of ownership transfer. So we're just transferring the ownership from one variable name to another variable name. So let's take a look at immutable borrowing. So in this case, we have S1 again. So we're assigning hello to S1, and we are going to get the length of the string. So we have a new function down below called calculate string, and it takes in a at string and it returns back a usize. Now, usize is a open-ended, kind of like a the compiler figures out the size that you need. So you can have an I size, a U size, an F size. It just means that I'm not going to explicitly say how large this variable type needs to be. I just need it to be big enough to handle the what is going to be returned back from this function. So U just means it's an unsigned decimal, or no, unsigned integer. I'm sorry. So U is unsigned integer. So because a length can't be negative, so that's why we're gonna have an unsigned integer. So in this case, the main function sends over a copy, a kind of a reference to an immutable value. So that's why we have a ampersand S1. We're saying we're not going to send over the actual memory space. We're just going to send over a copy of it for the other side. So in this case, we have the ampersand string, which means that we're going to accept a reference. So we're going to accept a value coming in, not a pointer coming in, which takes in S. So S dot length, which is a built-in function of a string, will send back the length. And that is why the last line of the function of main we can use S1 and length to build and print our string. So S1 never gave ownership to calculate length. It actually let the value be borrowed. So that's why we say borrowing. We can either give ownership, or we can allow the value to be borrowed to another block of code. So that's why when S1 was sent into calculate length, it didn't lose scope. It was still around because it actually still pointed to its own unique space of memory that contained hello. Hopefully everyone understood that. So we can also have mutable borrowing. So mutable borrowing is where we can send in something, we can change it in the calling function and then return the change back. So in this case, we are doing the same thing. We have S, which is a mutable string. So that means that we can modify the value for that variable. So it starts out as hello. We're going to send it into a function that's called change. You can see that change doesn't have a return type. So change will actually change the value of that mutable variable. So in this case, it's some string, and then we have to say ampersand mute to say this is a mutable string, and then we are going to say some string dot push string. So that just means that we're going to push a string into another string. So we're going to say hello, comma world, and we're going to return that. So we don't have to say return it. All we're saying is that at the end of this function, we have a string that was changed, and we're going to that memory space, which was kind of shared. So in this case, it was borrowing the actual pointer. So we're sharing the actual pointer from main to change, and then it comes back as S, and we can print it out. So that is how we can kind of send things in, mutable types, send those in and get them changed and return them and still use them in the original code function or code block. So transferring ownership to functions, again, we have a string. We're going to have a function called take ownership. So in this case, we are going to send over the ownership. We're going to say S, we are going to transfer the ownership of what S points to, which is hello, and we're going to send that over to take ownership. And in take ownership, we're going to print that string. And at the end of take ownership, some string goes away because there's no owner to some string anymore. So both some string goes away and the original block of memory that held hello also goes away. But we did print that out to wherever we were printing it to. Now, if we go back to main, you can see that I have a commented out line that also has that print line for printing S, the original value for that string of hello. And that would cause, if it wasn't commented out, that would cause a compile error because one, S is no longer the owner of that block, so it goes away. And the block, the actual memory, no longer exists. So nothing exists at the end of function main. That ownership has been transferred, and it lost its new owner, so it got put back into the big vast sea of memory, and we now printed out a string and everything's gone. So there are no variables and there are no memory for this little program. So returning ownership, this is another thing, and maybe, I want you guys to download the slide deck and take a look at this, because maybe it's pretty easy to walk through, but I want you guys to figure this one out. So this will take me like 10 minutes to kind of walk through. So I want everyone to download the slide deck. It's a way to force you to get the slide deck and take a look at this. So there's lots of different ways that we can do Rust ownership and borrowing, and this is another one that you guys can take a look at for ownership and borrowing, and you can walk through this. It's pretty good. This one is just comparing two strings together. And if you take a look, one thing I will tell you, if you take a look at the function longest and you see this tick A, so you'll see these at tick A's. That just is a way that Rust will allow a function to send back ownership of one of the parameters that was sent in. It's a little confusing. I understand it in a basic way, but this is where Rust people can get, it takes a while for people to really understand everything about Rust, and this is one of the reasons why. It has to do with ownership. It has to do with only, for the compiler, only wanting one thing to be sent back from functions. It's a little confusing. So I put it in here just to kind of say that Rust is a very hard language to fully understand, and it takes most people a while to master. So concurrency. So one of the big reasons why people use Rust is for concurrency. That's why Microsoft has been really recoding or refactoring Windows from C++ into Rust, is because there was a lot of errors, and there was a lot of issues with concurrency in the Windows code base, and there was a lot of ways that C++, just like C#, can have concurrency issues because of the way that it allows variables to be shared in threads and different ways, and developers can really mess up their code if they don't fully understand the concurrency models for the languages that they're working in. Which Rust, if it detects that you're going to have concurrency issues, it will not allow the program to be compiled, which is awesome, I think. So for C#, we have this asynchronous programming model. We see it every day. We have async task, or async task of a type, which just means that we are going to return back something that may not be done yet, but at some point that task will be completed and returned. So, and we're just waiting around, and the rest of our application code can still work, because it is in an asynchronous programming model, where if it was synchronous, our program would actually halt and have to wait for that work or that code to be done, and those values or types to be returned back from that function or method. In Rust, it has to do with ownership. So each value in Rust has a single owner, and when an owner goes out of scope, the value is dropped. We've already talked about this. This ensures that memory is safely managed without manual intervention. So borrowing, we've taken a look at borrowing. Borrowing allows references to values to be borrowed either immutably or mutably, and immutably borrows references can be shared, but mutable references are exclusive. Uh, that's pretty straightforward. Mutable references are exclusive because that value, a copy of the value, got sent into that mutable reference, which only exists in the scope of that function or code uh, uh, block. But exclusive access, so this is a big thing. So Rust borrowing rules ensures that mutable references are exclusive, preventing data races. So because if we're sending mutable variables around, we're just getting copies of that, which will not have conflicts with two things pointing at the same value or at the same memory space. If a value is mutably borrowed, no other references to that value can exist, ensuring that only one thread can modify the value at a time. So this is how we in Rust, we can have kind of thread safe understanding. And then Rust also has some special traits that manage concurrency. We have this idea of send and sync, and we'll take a look at that in a second. Compile time guarantees. So the compiler enforces rules to ensure that data races and other concurrency issues are caught at compile time instead of runtime. So a lot of times with C#, we have to pick up a lot of these errors at runtime and then code for those after we learn what happened during runtime. So for Rust, once someone masters Rust, their programming in their code is a lot safer and a lot error prone, or less error prone, because they understand the concurrency model, plus the compiler will look for those issues and block the compilation of the application or the code. And then concurrency primitives. There is a standard library that Rust has for concurrency primitives like threads and channels and locks, which also help for Rust to ensure a more safe concurrent execution. And we'll take a look at that right now. So in Rust, we have this library called MPSC. I do not know what it stands for, but it is a library that we can use, and it has a type called channel. And channel, as you can see, it has TX and RX. So it actually has two endpoints that get returned back, and we can use those two variables to do different things. TX is where we can send, we can transmit information, and then RX is where we can receive. So we can see that down here we have a thread that spawns that is going to transmit a string of hello world. And then we have some other code in this main that lives outside of the thread that will receive that that transmission and print a line basically saying what was received. And then we will say handle, join, unwrapped, and that just means that the handle will go away. So this is a simple way to kind of show this concurrency, how we can do threads and how we can kind of use this type called channel to transmit and receive. So it has nothing to do with like TCP/IP. It's basically just a way for threads to send back information that needs to be handled later in the application. Any questions on this? So I don't even know what time it is. It is, oh, we are at about 1 hour. So we're almost done. We're just going to go through some benchmarking and some resources, and then we'll be done. So give me 15 minutes. So let's benchmark. So, I talk about Rust being efficient and uses less memory, uses memory a lot better. But let's show some benchmarks to show that it is. So speed. So this was a test for the Mandelbrot. So Mandelbrot is like a fractal calculation. So this is the log time to produce 1600 to the second Mandelbrots. It's some fractal calculation that is some standard for benchmarking. And as you can see, there's a bunch of languages here. That's where C# kind of lives. Lives in that second kind of tier, very respectable. It kind of lives in where Java, and we can take a look in Go and Pascal, if anyone has worked in Pascal anymore. But we can see that there are some other languages that take a much longer time. So in that fourth column, it would be Ruby and Python. PHP would be in that fourth. But if we take a look at where Rust is, pretty much the only thing that is better than Rust in this benchmarking kind of competition is C++. So Rust is pretty good. Rust is very good at speed. So if you need something that is blazing fast, Rust could be a good contender for that type of programming. So how about power consumption? So in today's world, we have a lot of people saying that software should be green, only use software that uses less energy, and energy is becoming a commodity. Not even a commodity, it's becoming scarcer and scarcer now that we have AI and these huge data centers. AI uses up as much power as the country of Argentina, I heard, on a daily basis, which is kind of scary. But as we can see, C# is sitting down maybe not quite halfway, but around the middle, respectable number. It's not as bad as like Python and Perl and TypeScript. TypeScript is, wow, I never thought TypeScript was that bad, but it's even better than JavaScript and F#. But that's Rust. So Rust uses, even though it's not faster than C++, it uses less energy. So the only thing that uses less is C, which C is pretty much the basic on the metal language. So I can see where C is kind of that benchmark that everyone starts with. So my surprise was Java, how kind of low energy wise Java was compared to C Sharp. So I never thought that it was that that more power. It used that less of power compared to C Sharp. So ecosystem and tooling. So, this is, if you're going to program in a language, you got to understand the language, the tools that developers use. So let's take a look at the ecosystem and the tools that we use. So overview of .NET, we'll quickly go through this. There's Visual Studio, Visual Studio Code, my favorite, JetBrains Rider, NuGet. So everyone knows NuGet for packages. ReSharper, and then I just threw Lincoln and LinkPad. So tools that we can use. And there's some other ones, EF Core, Blazor, SignalR, Dapper. I mean, .NET has a very extensive ecosystem for libraries and tools. So let's take a look at Rust's ecosystem in the tooling. So we have Rust, we have this thing called crates. So crates can be thought of kind of like NuGet packages. So Rust has crates that you can import into your application and you can use. We also have Rust-up. So Rust-up is the compiler. So Rust-up is like the tool chain that basically brings everything together and builds it into one application. We have Clippy. Clippy is a linter. So for if you've ever done like JavaScript, there's like ESLint and stuff like that. Well, Clippy is the linter for Rust. You can run your application through Clippy, and you can have rules that will allow beyond just the compilation rules. Like you can have your own rules that will say yes or no to certain ways that people are programming their Rust code. And then you can have Rust FMT, which is Rust formatter, which it will just reformat your Rust in a specific way, and that is all configurable. It does have a good kind of default format value, but you can change it around if you want. So people use Visual Studio Code to do Rust. JetBrains has a IDE called Rust Rover that came out last year or earlier this year. It's actually free for non-commercial use and personal use. So it's the IDE that I use. It's awesome. I love it because it gives you all the features that you expect from JetBrains IDEs, but it also brings in a lot of that ways to work with those stuff up in the top row. So I like it. Then there's Actix, which is a web framework library. Rocket, which originally started, and I used it to create web APIs, but it has expanded and you can do web development in it. Warp, which is a web development, and Poem, which is another web development. So there are lots of different ways and frameworks that you can do web development. I didn't put anything else down here because most people are web developers, so I did want to show that there are multiple frameworks out there to do web development in Rust. So learning path and practical tips. So let's if you do want to learn Rust, this is kind of where you should go and what you should use. First, there's a free resource called the Rust book. People just call it the Rust book, and it's free. It's out on the web, out on the Rust website. It's extensive. You could learn all of Rust just from this one resource. It's in HTML format, but I think you can get a printed, you can get it in paperback and ebook format from No Starch Press from another website, but I think those cost money. Another great resource is Rust by Example. This is also out on the Rust website. This has tons of different learning examples that you can go through to learn pretty much everything that you want to learn about Rust. And then there's Rustlings, which are kind of little exercises. I think they're kind of like Kanban, or what were those the little exercises that
katas.
Katas, yeah. It's kind of like katas, but they call them Rustlings. So you can do that, and that is out on GitHub. If you do want a book, this is the book that I've been using. It's O'Reilly's Programming Rust. Came out in 2021, still very viable for Rust. Rust doesn't kind of change very fast. They try not to kind of change things too much. But so this book is awesome. It's very extensive, and between this book and those 3 other resources, pretty much that's all that you need to master Rust, I think. But if you did want to kind of get help, there are Reddit resources, there's Discord services, or there is a huge Rust Discord server. JetBrains does have a Rust training in one of their add-ins, their JetBrains Academy, which you can load into your IDs, and actually it will walk you through, kind of like Rustlings. It will walk you through a lot of exercises and coding examples that will teach you Rust from beginning to end. And if you want to keep up with the Rust community, there's This Week in Rust, which comes out every Thursday. So I think it came out today. Either it comes out on Wednesday or Thursday. But it's a great resource to use. Gives you kind of all the new things, blog posts, what people like, podcasts. They do a great job of compiling all the new information from the last week. So I'll open up for questions, but I do want to, I've got to pitch stuff that I do. So I am writing a book. I'm writing a book on C# networking programming. So it's actually free. It's actually up to chapter 10 now. I'm almost ready to release chapter 11, which is web RTC. So you can go out to c#-networking.com for that. And then I do a podcast every 2 weeks called The Breakpoint Show with 2 friends that both of them work at JetBrains. We talk about a little bit of everything. It's on YouTube, and you can get it from pretty much any podcast aggregator. So that, and there is the QR code to to get the to go to the repo that has, I say all the code. There's no code yet, but it has the slide deck. So at this point, I will answer any questions, or I will let you eat your virtual pizza and your virtual beer. That's the one thing I miss about user groups is going out after user group meetings and sharing a adult beverage and conversation with people. So
Most definitely. I missed that as well. I don't think there's any other questions in the chat.
okay. So well, I hope it was a good hour and 15 minutes. Rust is a I will say Rust is a very hard language to learn. But once you learn it, I think it's a good tool in your tool belt to use in the future.
Definitely. All right. Well, thank you very much, Chris. It was a great presentation. I dropped the link in the chat for the survey. I also have the QR code up on the screen. If you want to take a picture with your phone, do it that way. That's cool too. I'll leave this open until about 8 p.m. tomorrow night. So we've got 24 hours to mull it over if you need to and leave your feedback. All right. Thank you, Chris.
See you later.